Einstein was wrong. I'm sure you've heard of the theory of general relativity, Albert Einstein's theory of gravity, and the reigning king when it comes to rationalizing the fabric of the universe. The theory of relativity posits that space-time, existing as a kind of four-dimensional fabric making up the universe, is warped and curved by the presence of mass, creating gravity. Think of it like this. The universe is a very large, fireproof trampoline, pulled taut, and you drop the sun on it. Now you probably know that the sun is quite heavy, and so it would make a dent in the trampoline. Now drop the Earth next to it. You'll notice that even though the Earth makes its own dip, the sun is making a dent so big that it is causing the Earth to roll towards it anyway. It's a very simplified way of explaining Einstein's theory of relativity, but it gets the idea across. However, there is a problem. While Einstein's theory has not failed under direct testing, it does contradict quantum theory. What is quantum theory? In a word, weird. For example, single particles can be in two places at once until observed. This phenomenon, known as quantum entanglement, freaked Einstein out so much he called it spooky action at a distance. If the theory of relativity says matter and energy warp spacetime, but quantum physics says both of these things exist in multiple states simultaneously, what happens to the gravitational field? It's hard to reconcile. Then there's the issue of singularity. A singularity is an extreme situation in which gravity forces an object of enormous mass to fit into an incomprehensibly tiny space, such as the center of a black hole or the beginning of the Big Bang. At singularity, pressure and energy density become infinite. There is no space-time, because space and time mean nothing. In this situation, relativity cannot exist. There are several leading theories which attempt to accommodate both quantum mechanics and general relativity, potential theories of quantum gravity which apply in singularity. You've probably heard of string theory at the very least. There's also loop quantum gravity and modular space-time theory. All of them have different pros and cons, but they all also agree that general relativity does not work at the fundamental level. However, testing these theories has proven difficult. Because quantum gravity only exists in extreme situations like singularities, to mimic such conditions, we would need a particle accelerator the size of a galaxy. Our best bet at the moment is cosmology. If we turn our eyes to the skies, we may be able to prove parts or all of one or more of these theories. That won't be feasible for a while, though. However, in a century or three, quantum gravity might be the foundation of modern technology.